Earth, a 4.5 billion-year-old planet, still evolving. As continents shift and clash, volcanoes erupt, and glaciers grow and recede, the Earth's crust is carved in countless fascinating ways, leaving a trail of geological mysteries behind. And one of the greatest is right here at Yellowstone National Park in Wyoming. This is one of the world's most geologically active places, shaken by up to 5,000 earthquakes every year, and with more geysers and hot springs than in the rest of the world combined. Why is Yellowstone so active? How did it form? And why here in the heart of the Rockies? Scientists studying Yellowstone are uncovering a violent past, carved by water, crushed by ancient glaciers, and blasted by the biggest volcanic eruptions ever known on the planet. And even today, Yellowstone is one of the most dangerous places on Earth. Yellowstone National Park is one of the most amazing places on Earth, and it's unique. It contains some of America's most stunning scenery and wildlife that attracts 3 million tourists a year. To understand where Yellowstone came from and why it is so active today, we need to take a journey back into the distant past of the North American continent and deep into the Earth's interior. Yellowstone sits 8,000 feet up on a remote mountain plateau, primarily within Wyoming, but stretching into parts of Idaho and Montana. The park covers 3,468 square miles, 63 miles north to south, 54 miles east to west. And it's on top of one of the world's most unusual and deadliest geological structures.
What's unusual about the park? Are the wildlife unusual? No. Is the wide open space unusual? No. You've got it all over the western U.S. What's unusual? It's a very unusual geology that created the park. Yellowstone was founded as the world's first national park because of the geology.
It's this strange geology that attracts teams of scientists to the park. Their task? To piece together the story of the incredible processes that built this unique, extraordinary landscape by digging deep into Yellowstone's past.
The geologic history of Yellowstone goes back to the formation of the North American continent. Some of the rocks in Yellowstone are 2.8 to 3.2 billion year old rocks, some of the oldest in North America.
Only by traveling back into the past can we figure out why, in this particular location, there are 2,400 miles of rivers, more than 300 waterfalls, and the world's greatest concentration of 10,000 hot water springs, bubbling mud holes, gas vents, and geysers. What do these features reveal about this landscape and how it was formed? The investigation begins at Yellowstone's star attraction, Old Faithful. It's a key clue to what's going on underneath the surface. Located in the southwest of Yellowstone Park, the geyser puts on an explosive display every 90 minutes or so, blasting out thousands of gallons of scalding hot water.
Yellowstone is like no other place on Earth. There is so much heat coming out here. It's really a singular phenomenon. Well, after about a 90-minute nap, Old Faithful has roared back to life. It wasn't actually napping, it was recharging. The temperature of the water was increasing, the system was pressurizing. Beneath Old Faithful is a rather complex plumbing system filled with caverns and conduits and constrictions.
Rainwater saturating the ground around the geyser slowly fills its underground reservoir. Hot rocks below ground heat the water under pressure for around 90 minutes. Suddenly, some water spurts through a tiny 5-inch wide crack in the rocks. This causes a drop in the pressure within the water chamber. In an instant, thousands of gallons of water are turned to steam and blasted up into the air.
When the pressure builds up enough, steam bubbles start rising to the surface, the system depressurizes, and the full eruption can occur.
Old Faithful shows that rocks below the surface are very hot. Scientists find clues to a violent past 34 miles southeast of the hot springs, on the shores of a circular lake called Indian Ponds.
As a field geologist, my job is to basically be a rock detective. And so I try to determine what their origin is and what the history is of that particular rock. There we go. Okay, now in this particular case, let's look at this. This rock, when it started, it was just a loose sand. You could just put your fingers through it.
The solid boulder is formed from millions of individual grains of sand. Microscopic analysis reveals the grains have been cemented together by chemicals and pressure deep under the ground. But how did the rock get to the surface? Morgan has chemically dated the rocks and discovered that 3,000 years ago, the boulder was blasted out of the ground by the hot water explosion of a gigantic geyser.
You would see boiling water, rock fragments, and fine muddy material being ejected up into the air as high as 3,000 to 5,000 feet. And then at some point, material would start raining down from this explosion column. Now, you wouldn't want to be standing next to one of those.
Indian Ponds is the crater that the geyser left behind. But it is dwarfed by the crater Morgan has found at Mary Bay in Yellowstone Lake. Morgan has dated this geyser explosion to 13,000 years ago.
So here we are in the middle of Yellowstone Lake, and it's, as you can see, a beautiful day, and it's nice and placid. But on the floor of Yellowstone Lake, it's anything but quiet.
Morgan's research proves that geysers were exploding around the lake and even under the water between 13,000 and 3,000 years ago. And their size suggests that whatever was powering them was huge. But is it still active today? A clue comes from underwater vents at the bottom of the geyser crater. They pump out vast quantities of hot water and gases. To find out what's creating the gases, Jake Lowenstern and his assistant collect samples from the hot springs in the center of the park. The funnel they use is designed to collect up gas bubbles before they reach the surface, so that they're not contaminated by ordinary air.
So let it sit for 5 minutes, let the oxygen get out?
Yeah. It is a very complex mix of gases, but we have a lot of tools that we can use to try to unravel this rather complicated information. So we'll look at all of the gases that are coming out. We can learn about the different kinds of rocks beneath Yellowstone and try to understand how things might be changing from week to week or year to year or decade to decade.
Analysis